Hey guys, welcome back. In this lecture, we will learn how to read a data of post-processing mode and draw a diagrams of bending moment, shear force, and deflection. So let's start with the previously solved continuous beam. Just analyze this one first. Go to analyze, print, add and close, analyze and run analysis, save. Go to post-processing mode and done. You can interchange the modeling and post-processing mode like that. Okay, so it's a diagram. This is a deflected shape of or displacement of a beam. Just go to results, view value, beam results and maximum resultant in displacement. Just check mark on that box and click on annotate. You can see all the maximum values of deflection for all the beams are displayed on a screen. So like that you can find out the maximum value of displacement on each beam. Okay, again go to results, view value, beam results, uncheck the displacement and click on annotate, close the displacement diagram, go to MZ for bending moment, results, view value, beam results, in bending, check mark in end, maximum and midpoint. Click on annotate. You can see all the values like bending moment at the end of the beam, at the mid of the beam, and the value of maximum bending moment in all the beams. For the first beam, in first end there is a pin support, so bending moment is 0. At the mid of the beam there is bending moment of 3.304 kilonewton meter. At the another end there is the maximum bending moment of 14.553 kilonewton meter. For a second beam, the maximum bending moment of first and second beam is same, 14.553 kilonewton meter. At the mid of the second beam, the bending moment is minus 9.382 kilonewton meter. At the another end of the second beam, there is the bending moment of 4.433 kilonewton meter. Like that you can find bending moment at the end, mid and the maximum bending moment in all the beams. Okay, just close it, view value, beam result and uncheck all the box of the diagram of bending and open a shear force diagram. Just click on FY, control and scroll down, go to results, view value, beam results and check the shear values and maximum and mid. Click on annotate and close. You will find all the maximum values, mid values and end values of shear force for all the beams. Look at the first beam. In first end, there is some shear force of 1.445 kilonewton. At the mid of the beam, there is a shear force of 0.208 kilonewton. The last end of the beam is the maximum shear force of minus 18.355 kilonewton. Like that, in second beam, there is a maximum shear force at the first end of 18.324 kilonewton. At the mid of the beam, there is a shear force of 0.824 kilonewton. The last end of the beam, there is a shear force of minus 2.676 kilonewton. If there is some confusion, just go to beam cursor, select that particular beam, go to view and view selected object only. You will find that particular beam only. So just read the data. At the third beam, in first end, there is a maximum shear force of minus 1.047 kilonewton. At the mid of the beam also same, and the last end of the beam also it is same, because in this beam there is no load. Just go and watch the previous video or display hole structure from that icon. Take a front view. You can show all the loads in this diagram also from this icon load. Just click on the loads. Look at this, there is no load. Okay, so shear force will not change throughout the length of the beam. The last beam, there is some shear force of just on that data, annotate. At the last beam, there is a maximum shear force of 11.894 kilonewton. The mid of the beam, 11.894 kilonewton. At the end of the beam, minus 8.106 kilonewton. So like that you can see all the maximum values, end values and mid values for shear force, bending moment and deflection. Alright, now again go to post processing and look at this table. In this table, there is a beam relative displacement. All relative displacement and maximum relative displacement. The first column is for beam number. In this beam, just press Shift plus B to show beam number. This is your first beam, beam number 1, beam number 2, beam number 3 and beam number 4. Okay, this is very important, guys. So first beam, load case 1, the distance is 0 meter and a displacement is also 0. Okay, the distance 0 meter means at the start of the beam, at the start point of the beam, there is no deflection. Look at the deflection diagram. At the start point of the beam, there is no deflection. Okay, at the 1.25 meter distance, which means somehow in this point, at the 1/4 of the beam length, there is some displacement of 0.173 mm. So at this point, there is a deflection of or displacement of minus 0.173 mm. Okay, at 2.5 meter, which means at the center of the beam, There is also some displacement of 0.225 mm, which is a maximum displacement. Okay, you can see at the maximum relative displacement. Look at the 3.75 meter distance, which means somehow here there is a displacement of 0.083 mm. At the last point of the beam, there is no deflection at the 5 meter length, means the end of the beam. The last point of the beam, there is no deflection, which is 0, 0, 0. Okay. In second beam also, beam number 2, this one, load case 1, 0 means the start point of the beam. There is no deflection at the 1.25 meter length, which means somehow here, this location, there is a deflection of 0.448 mm. At the center of the beam, there is a deflection of 0.770. At the 3.75 meter length, there is a deflection of 0.523 mm. At the end point of the beam, there is no deflection, which is 0, 0, 0. Like that, you can find a deflection in all the beams, beam number 1, 2, 3, 4, or whatever. For maximum relative, go to the maximum relative displacement, beam number, load case, length of the beam is 5 meter, and the maximum resultant at the distance of 3.333 meter, and the value of displacement is minus 0.229 mm in y direction, in vertical direction. Okay. In second beam, the beam length is 5 meter, and at the location 4.583, the maximum resultant displacement is 0.770 mm. Like that, you can see in third and fourth beam at the distance and the value. Just go to the reaction and you can find all the reactions like X, Y, and Z at the support, and MX, MY, and MZ. If you apply fixed support, it will show all the reactions, reaction in X direction, Y direction, Z direction, movement in X and Y and Z direction. Okay, since it is a pin support, so it shows a movement is free. Look at this table. There is the node number, load case, and a reaction, vertical reaction in Fy in kilonewtons. In first node, to show node number, just press shift plus N. This is your first node. In first node, there is a reaction of 1.445 kilonewton in vertical direction. We did not apply a load in X and Z direction, so reactions are 0, 0. We applied load in Y direction, vertical direction, so reaction will also come in only vertical direction. In node number 2, there is a reaction of 36.679 kilonewton. Look at this. Okay. In third node, there is a reaction of 1.629 kilonewton. In fourth node, there is a reaction of 12.941 kilonewton. In fifth node, there is a reaction of 8.106 kilonewton. Check results. All the reactions, sum of the all the reactions should be equal to sum of the all the loads. Okay, so loads applied 60.8 kilonewton and reactions also 60.8, which is a good, okay, a correct. Go to beams. If you click on beam, the bending moment diagram will automatically on, and from this table you can find out all the bending moment and shear force values. Look at this in this table: beam number, load case, distance 0, 1.25, 2.5, 3.75 and 5. Okay, and the value of shear force in Fy and the value of bending moment in Mz. Value of shear force in Fy and value of bending moment is in Mz. Okay, look at this. At the start of the beam, there is some shear force of 1.44 kilonewton just on the shear force diagram also. The blue one is shear force diagram and the red one is bending moment diagram. Okay, and the bending moment is 0 because it's a pin support, so there is no bending moment. 1.25 meter, at the distance of 1.25 meter, there is some shear force of 1.44 kilonewton and a bending moment of minus 1.807 kilonewton meter. Right? At the center of the beam, at distance 2.5 meter, there is some shear force of 0.208 kilonewton and a bending moment of 3.304 kilonewton meter. Okay, so like that you can see a bending moment and shear force values from this table at the 5 different locations of each beam for all the load case. In this beam we applied only one load case as a load. Go to maximum axial force. In the axial direction there is no force, so all the reactions are also 0, 0, 0. Go to maximum bending moment. It will show a maximum bending moment at all the beams, negative and positive. First beam, load case 1, maximum positive value is 14.553 kilonewton meter bending moment, and the maximum negative bending moment is minus 3.304 kilonewton meter. Okay, for second beam, the maximum positive bending moment is 14.553 kilonewton meter. The maximum negative bending moment is 9.382 kilonewton meter. Like that you can see a bending moment values, maximum bending moment values for third beam and fourth beam. Okay, next is maximum shear force. You can see maximum shear force values for beam number 1. Positive shear force is 1.445 kilonewton and a negative shear force is 18.355 kilonewton at the distance of 5 meter, and the positive shear force is at the distance of 0 meter means start point of the beam and 5 means at the end point of the beam. Look at this. Okay, at this point there is the shear force of 1.44 kilonewton, and at the end of the beam, first beam, the beam number 1, okay, the negative shear force is 18.355 kilonewton. Alright, like that you can see a maximum shear force values for 2, 3 and 4th beam. Okay, just go to the graph. Look at the graph. Just click on first beam. The first one is the bending moment graph. Second one is a shear force graph, Fy. And the third one is axial force graph. Click on the second beam. Mz bending moment graph, Fy shear force and Fx axial force. Click on the third beam. Likewise, you can see all the graphs and diagrams of bending moment, shear force and axial force. Okay, thank you. Thanks for watching this.